Hello everyone, welcome to session 2 of LTEC 651 Interactive Multimedia Production. In this video, we're going to talk about 4 things. First, we'll talk about varying levels of analysis in the social and cognitive sciences. Next, we'll recap the 3 assumptions Mayer draws on to form his cognitive theory of multimedia learning. Third, we'll break down the various types of processing that contribute to cognitive load. And finally, we'll close out by reflecting on Wesch's video, "The Machine is Using Us." So let's get started. I want to begin by talking about the different levels of analysis that are possible when thinking about multimedia. To do this, I'm going to draw on levels of analysis that are typically associated with the social sciences and cognitive science. I'm doing this because I think it's going to help us get a better sense of what is meant by the cognitive perspective, which is an important point of view for designing effective multimedia. Essentially, there are 5 levels. Let's start in the middle at the individual level of analysis. This level of analysis deals with individuals in their social settings. In the social sciences, this is called the micro level of analysis, suggesting it's the smallest unit of interest for researchers. So what constitutes an individual? Well, an individual might be a worker, or a voter, or a user of some technology. In education, we are often thinking of individuals as being learners. So when we're thinking about multimedia at this level, we're thinking about how individual learners process and make sense of, and hopefully learn from, multimedia messages. Now let's contrast this with the next level up, which is the interpersonal and/or group level of analysis. Now this level of analysis deals with subpopulations of people, such as communities or organizations. In the social sciences, this is referred to as the meso level of analysis. For instance, in education, we might talk about how private schools in Hawaii use multimedia compared to public schools. In this example, we're not looking at individuals, rather we're analyzing how different organizations or subpopulations use multimedia. As another example, we might compare how preschool students process multimedia messages differently than middle school students. The point is that the interpersonal/group level of analysis is different than thinking about how individual learners process and learn with and from multimedia. Next, at the top level, we have the socio-cultural level of analysis. This level deals with large populations. In other words, how does society as a whole react to and interact with particular phenomena of interest, such as television, the internet, or the emergence of multimedia? These innovations impact all of society. For example, if we're interested at the socio-cultural level of analysis, we might analyze how one culture uses multimedia to communicate compared to another culture. Again, we're talking about entire populations here, which is a different vantage point than thinking about organizations or individuals. Simply put, the level of analysis is different for each of these levels. Now, these 3 levels aren't perfectly cast in stone, and one isn't inherently better than the other, and in fact, they're all relevant and applicable within the field of education. However, I wanted to distinguish between these levels here in order to emphasize that in LTEC 651, we'll be focusing on the individual level of analysis. In other words, we're investigating how to design multimedia when thinking about the needs of individual learners, working one-on-one with a multimedia message intended to foster learning. Of course, just like we can go up levels, we can also go down. For example, under the individual level of analysis, we start to open up the black box of human cognition. This is where we get into cognitive science and its goal of understanding and explaining how the human brain works. This level is called the cognitive level of analysis because it focuses on how mental processes such as perception, attention, language, memory, and thinking actually enable us to process information. It focuses on how we as humans take in information from the outside world, attempt to make sense of it, and ultimately how we use that information to accomplish our goals. Based on that description, I hope you're seeing the connection to Mayer's cognitive theory of multimedia learning. His theory is based on assumptions about the ways humans process information as individuals. This is why it is called the cognitive theory of multimedia learning, as opposed to the social theory or the cultural theory. The level of analysis is at the cognitive level, which informs how we design multimedia for individual learners. And last but not least, we can go down one level further to the biophysical level of analysis. This level of analysis focuses on the physiological basis for cognition, emotion, and behavior. It's the stuff of neuroscience. Now, in education, we typically don't go down to this level, but we should be aware that it's there and that there are researchers thinking about the structure and function of the brain from this point of view. Okay, that's all I wanted to share about these levels of analysis right now. The main point I want to make is that in education, when we're talking about the cognitive perspective, we're primarily concerned with how our human brain, with all its strengths and weaknesses, shapes the thoughts, emotions, and behaviors of individuals, or these two levels right here. Okay, let's move on. Now I'd like to review the 3 cognitive assumptions on which Mayer bases his cognitive theory of multimedia learning. The first assumption is the dual channel assumption. This assumption is based on the idea that humans possess separate information processing channels for visual spatial material and auditory verbal material. Basically, it is believed that information presented to the eyes is processed in the visual channel, whereas information presented to the ears is processed in the auditory channel. Now, here's a question. What are the implications of this dual channel assumption on how we design multimedia instructional messages? Well, the assumption suggests that well-designed multimedia should leverage both the auditory verbal channel and the visual pictorial channel. While this seems common sense today, we have to remember that the ability to create instructional materials that combine audio and visual material easily is a relatively recent phenomenon, facilitated, of course, by the advent of the computer. The next assumption is the limited capacity assumption. Of course, this assumption is about the fact that humans are limited in the amount of information they can process at any one time. It's no secret that our working memories are very limited. And you've probably heard the rule of thumb that suggests we can only hold 5 to 7 chunks of information in memory at a given time. This is why phone numbers were designed to be 7 digits in length. And believe it or not, more recent research argues that the real amount we can hold in memory is even less, more like 4 pieces of information. As people engaging and interacting with a sensory-rich world, our limited working memory capacity forces us to make decisions about important things. Some of these decisions are conscious, and sometimes they're unconscious. For example, we have to decide which pieces of information we're going to pay attention to. We can't pay attention to everything happening in the world. We also have to make decisions about the degree to which we're going to process or build connections between the information we've decided to pay attention to. And finally, we have to make decisions about the degree to which we're going to build connections between the information we have in memory and what we already know, our prior knowledge. Of course, all of this has implications for how we design multimedia instructional messages. Essentially, the limited capacity assumption means multimedia designers should limit the amount of material being presented at any one time, and they should never force learners to hold large amounts of information in their memories. The final assumption Mayer draws on is the active processing assumption. This is my favorite one because it essentially acknowledges that learning is hard. It takes effort. Humans don't automatically process and make sense of information coming from the outside world. It's hard work, and it involves selecting relevant incoming information, organizing that information into a coherent cognitive mental representation, and then ultimately integrating it with other knowledge that is already stored in long-term memory. From the cognitive perspective, these 3 steps, selecting, organizing, and integrating, is what it takes for an individual to learn something new. And importantly, we have to acknowledge that each step requires effort and attention on the part of the learner. In short, learning is not a passive process. The implications of the active processing assumption for how we design multimedia instructional messages is critical. Basically, we should ensure that the material presented to learners has a coherent structure and that the messages provide guidance on how they should build that structure mentally. Now, before we go to the next section, I want to underscore the idea that all learners are more or less the same from a cognitive perspective. After all, when we're talking about learners in education, we're talking about humans with the same cognitive architecture. And because of that, learners should be viewed as active processors of information that have two processing channels and a working memory that is limited in capacity and duration. Now, despite these common cognitive characteristics, learners can differ in a number of important ways. For example, learners can differ in terms of their working memory capacity. This affects their ability to select, organize, and integrate information. They can also differ in terms of their cognitive and metacognitive strategies. These strategies are the tools learners use to engage in generative and essential processing. These are the things that can be taught and learned, and therefore individuals are going to differ in their ability to process information based on the strategies they know about and that they actually employ. And finally, learners will differ in terms of their prior knowledge. Think about the differences between a novice and an expert. What you know ahead of time is going to greatly influence your ability to process information. Specifically, familiarity with a topic helps learners handle extraneous processing and/or guides their essential and generative processing. This is why, as educators, we are often trying to activate prior knowledge, especially in children. So that's a quick recap of the 3 cognitive assumptions Mayer discussed. If all of this feels a bit abstract right now, don't worry. We'll be looking at specific multimedia design principles and evaluating the extent to which they account for these 3 aspects of Mayer's theory. Okay, now let's take a look at cognitive load and the different types of processing that can occur while learning something new. But first, what is cognitive load? Well, cognitive load is the cognitive effort or the amount of information processing required to perform a task. And basically, as Mayer explains, there are 3 possible sources of cognitive load: essential processing, extraneous processing, and generative processing. So let's take a closer look at each of these. First up, we have essential processing. This refers to cognitive processing aimed at mentally representing presented material in working memory. This presented material could be from a textbook, from a lecture, from an instructional video. It doesn't matter. What matters here is the representation of whatever is being taught. Now, importantly, essential processing is caused by the inherent complexity of the material. It involves selecting relevant information from a presentation and organizing it in the mind. Ideally, essential processing is going to result in the construction of a representation in working memory that corresponds to the presented material. Now, since essential processing is caused by the inherent complexity of material, different topics are going to be more or less complex. For example, in school, think about how the number system is introduced to children. Students are typically introduced to natural numbers first because they are the simplest. Gradually, students learn about whole numbers and integers, as well as rational and irrational numbers. Each of these areas of the number system has a different inherent complexity. Therefore, the essential processing required to represent these concepts in working memory is different. Another example comes from the expression, "it's not rocket science," which is a phrase meaning something is pretty easy to understand. The joke, of course, is that rocket science is a very complicated topic. Its inherent complexity is very high, making it difficult for most people to understand and learn. In other words, the essential processing required to work on rockets is much greater than the essential processing required to do basic addition. As multimedia designers, we have to be aware of the inherent complexity of the material we're going to be representing. Now, the next type of cognitive load is the result of extraneous processing. This refers to cognitive processing that does not support the instructional goal. It doesn't come from the inherent complexity of the material being learned, but rather it comes from poor instructional design. Importantly, extraneous processing doesn't result in any useful knowledge being constructed in working memory. Essentially, it's wasted effort. A funny example of extraneous processing is from a Udacity course on learning to be a teacher. Imagine your task is to teach a young child how to walk. A really bad instructional design decision would be to teach the child to walk on ice. Think of all of the effort the child would have to put in to make sense of walking on ice and its slipperiness, none of which is helpful for the task of actually learning to walk. That's an example of extraneous processing. Another concrete example is shown here. Imagine teaching a child to solve 2 plus 3. But here we see blinking digits, meaningless colors, and other distracting animations. A learner new to the material would not know if the colors or the movement are meaningful or not, and therefore they would waste precious cognitive resources on trying to make sense of that information. And again, none of that processing would result in any useful knowledge related to how to add 2 plus 3. Again, it's an example of extraneous processing. The third type of cognitive load is the result of generative processing. Generative processing refers to the cognitive processing dedicated to making sense of presented material. It is caused by the learner's motivation to learn. And this type of processing involves organizing the incoming information, integrating it with relevant prior knowledge. Ideally, generative processing results in the construction of an integrated mental model. In other words, it is the processing that actually results in learning. I like to think of generative processing as the moment when a learner says, "Oh, I get it. That moment is made possible by generative processing." As multimedia designers, this is the type of processing that we want to promote. And over the next few weeks, we'll be looking at various strategies to help us do just that. Some of these strategies I'm sure you're already familiar with. For example, traditional textbooks try to facilitate generative processing by emphasizing key vocabulary, providing reflection questions, and using flowcharts and diagrams. Of course, you might be wondering, why are we talking about this? What does this have to do with multimedia production? Well, it has to do with multimedia production because in order to produce effective multimedia learning objects, we need to strive to do 3 things: minimize extraneous processing, account for essential processing, and promote generative processing. And as I said before, we'll be learning in the weeks ahead about design principles we can leverage to create effective multimedia instructional messages. Now, I want to end by coming back around to Wesh's video, "The Machine is Using Us." I enjoyed reading your critical reflections, and for the most part, I thought you did an excellent job analyzing the video. Of course, the issue I want to revisit today is whether or not Wesh's video is a good example of a multimedia instructional message. Most of you agreed that the video is creative, well-crafted, and entertaining. However, we can and should critique it from a cognitive perspective. And many of you pointed out some of these limitations of the video. So what are some of those critiques? Well, some of them might include arguing that the video presents too much information. It's visually very dense. We can also argue that the pacing of the presentation is too fast to foster meaningful learning. In addition, we might say that the music is catchy and fun to listen to, but it might not be using the auditory channel to full effect. In other words, to reinforce meaning. We might consider using audio narration instead. Further still, the video's editing style may have a negative impact on generative processing. There are lots of jump cuts, and it's hard to discern the various themes Wesh is exploring in his video. Finally, the fact that the video contains lots of jargon like XML, HTML, RSS might confuse some viewers depending on their level of prior knowledge with those topics. Long story short, Wesh's creation is a thought-provoking and inspirational video that uses words and pictures. But when viewed through the lens of Mayer's cognitive theory of multimedia learning, Wesh's video is not a very good example of a multimedia instructional message. Of course, creating such a message probably wasn't Wesh's goal. He was doing something more creative and less focused. The point, however, was for us in LTEC 651 to practice analyzing a multimedia object from a cognitive perspective, which we've done here and will continue to do this semester. Okay, everyone, that's all the time we have for today. Keep up the good work, and I'll see you in Canvas.